Hello everyone and welcome to this tutorial on Cartesian path planning using Move Group API. In this tutorial we are going to create a package which will allow us to plan a Cartesian path using C++ API which is provided by MoveIt. If you want more information about this API, please refer to this website. Here you can read all the documentation and the possibilities of using this API. So Move Group API will allow us to write C++ code to plan pose-to-pose goals or Cartesian path goals. There are a lot of possibilities and it's really useful when it comes to manipulator path planning. So please go ahead, read the introduction and read more information about this interface on this website. In our case, we will be reading an array of waypoints from a JSON file which we have created earlier, and we will create a path that will pass through those waypoints. So I have created the package actually, and it's a pretty simple process. I hope you have followed the beginner level tutorials on ROS-Wiki. So this package has a node called move. I will go over the code and explain it step by step. But before doing that, when you create this package, you will need to go to CMake lists and edit this file, add all those packages. So please go ahead, stop the video, add the dependencies in the CMake list and continue. After editing the CMake list, you need to edit the package XML, and you need to add the execution and build dependencies to this file. So we are going to be calling all of those packages in order to make it possible to plan the Cartesian path. So when you edit the package XML file, you can create a C++ file here, call it move, and then we can create a launch file. Launch file is also simple. It will just start a node of the type move group interface tutorial, and this node will be called here. So the add executable, this is the executable that will be called when we start this node. So to go over the C++ code, pretty straightforward includes. Those are the libraries that we'll be using. They're provided also and explained in the documentation. And then I have included JSON C++ to read the waypoints from JSON file, fstreams to open a file to allow a C++ to work with files. And by the way, if you're not familiar with JSON, JSON is a common format for configuration files, and it's used mainly in JavaScript. The idea behind those files is that we can store some configurations and parameters. It's similar to YAML files that you have seen in navigation in ROS. So we can store those files, those parameters in a configuration file, and then we can make changes to those files without having to recompile our code. So looking at the main function here, it's a simple ROS node, and then in order to set up the move group interface, you have to follow those steps. First of all, the move the planning group name, and then simple initializing and a constructor of the move group. So we're just passing the planning group name to the constructor, and it's just simple C++. After the setup, we need to create a namespace which we will be using in our phase to visualize our markers array and the path and the vectors of the waypoints. Then I have created a variable called visual tools of type moveItVisualTools. The visual tools is a class which will create all the visual elements in Arvis. So it will publish the path as a line, and it will publish vectors or points as arrows, and so on. So in case we had in our scene we had some markers or a marker array, I am clearing all of them here. So this line would clear all other markers that exist in the line. Then we have some title text, and that's it. So later, and this section here is the parsing section. We have created a buffer pose of type geometry messages, and in this temp pose, called the temp pose, I'll be storing each point that I'll be parsing from the JSON file. In fact, let me open the JSON file. This will make it easier to visualize or to understand what's happening here. So this is how JSON files look like, and this is an array. So here I have an array of objects. So this is an object, and starting with an array. So those objects will be parsed using JSON C++ library, and will be stored in a JSON value. So this is the part with JSON setup. We have a JSON reader which will read the file. We have a JSON value where we will store the file in, and then we have a parsing loop. So this loop, you can see it already. It's that the root, and then we have an index. So this point is index 0, 1, and so on. We are looking at each index, and then we're looking at each value or property of that object, and we are storing it in the temp pose. So the position or temp pose position x will have the value of px. So we're looping across the size of the array. So this array is 5 waypoints. So the size here will say 5. We'll be looping there for 5 times, and each time we parse an object or a pose, let's call it, we are storing it in waypoints array. So this is array of poses. Pretty simple, nothing special really. It's parsing a file, storing it in a buffer variable, and then storing this variable or the buffer variable in an array to be used later. So then I've declared a trajectory and 2 variables to store a jump threshold and end effective step. So the step will be here 1 centimeter. Our path will be planned with 1 centimeter steps, and then we have a function called compute Cartesian path. It's a function in move group class. So this function will create a path that will go through each waypoint of the array, and it's stored in a double variable, because later this function will return a double value which will say how much percent of the required path was planned. So maybe we will be able to plan 50% of this path, or 90, and so on. And we are using this variable to log the information later, and then the user will see a message, let's say something percent, 90% of the path was successfully planned, and so on. After planning the path, we are using again visual tools class to visualize this path in Arvis. So this is the function that visualize a line, and then we have a loop. This for loop will take a look at each waypoint that we have parsed from the JSON file, and it will publish an arrow with the orientation So Z, so you can see, you can switch it to publish Y arrow or X arrow. So we are publishing the orientation and the position, the orientation on Z and the position of each waypoint to make it clear and visually clear which waypoints we have passed already. And then the function trigger will start the visual process. So all of those arrows and a path will be called or will be published when we trigger the visual tools. It's pretty simple. You can find way more information on those on this API on the website that I have mentioned. So let's go ahead and test it. In this tutorial, I will not be launching the Gazebo simulation environment. I will use the demo launch file provided by the MoveIt configuration package. So let me go to catcan. Actually, I have I did run catcan make. So ROS launch, and then the package was called robot MoveIt, and then demo.launch. So this will start Arvis. And then we need to run the package that I have called move.launch. Before running this package, I will add a marker array. So this marker array will listen to the topic of that move group will be publishing the path on. So if we go back to the C++ code, this topic will be called it's the same as the namespace name, so it's Arvis Visual Tools. So that's the name of the topic. So marker array will listen to this topic, and we need to add a trajectory in order to look at the planned path and the manipulator movement. So now let's launch our package, and you'll see that the package did publish the path in red, and it also did, let me maximize it, it did publish all the waypoints that were used to create this path. We can I guess loop the animation. Yes, you can see this is each vector or each arrow would represent the end effector position at this waypoint. There are many possibilities that can be done with move group APIs, and for more information visit the website and take a look at what can be done using this API. It's really interesting. You can something that I would advise to look at is goal-to-goal planning with path constraints. That is interesting to look at, and take a look also at maybe at the move group Python interface. Python is really helpful when it comes to prototyping, and an interesting section in this documentation is I guess it was called planning motion planning API. Take a look also at collision objects and using different planners. It's pretty well explained, and yes, that's it for this tutorial, and see you in the next one.